Okay, good morning. Welcome back. Let's look at the schedule really quick. Today is September 16th. So we're going to clean up what we did on Friday. We're going to work a little bit with inequalities. And I'm going to let you keep on practicing your practice checkpoints that I gave you on Friday, and I got a couple new ones for you to practice as well. And then notice that we're actually going to take a test on all of this on Wednesday. Okay? So just a reminder, you have a lot of things due by Wednesday at 11 o'clock. You've got your Excel spreadsheet assignment with your quadratic equations, right? And let me remind you again that I will give you a chance to make changes to that afterwards, like after Wednesday. Like if you turn it in and you have a lot of things that are bad or wrong, I'm going to say, hey, check out this cell, check out this cell. I'm going to give it back to you and you can make changes and then resubmit it to me. Okay? But the other thing that you have to have done by Wednesday at 11 o'clock is all of those quizzes. And I saw a lot of you started working on 2.2, 2.3, 2.4, which is good. All the way through 2.7. Those you can do as many times as you want till you get the grade that you want, but come Wednesday at 11 o'clock, that's it. No more doing it after when you come to sit down to take the test, okay? Any questions on the schedule? Are we comfortable? Had it up there. Okay. What I'd like you to do, I'm going to go through a couple things, and then today is mostly just going to be work time. I'm going to go down to 2.7. This is under course docs and links. I have a couple documents here for you. The first thing, this is only 3 slides that I'm going to show you, and most of you probably already knew this, but this is good review. When we get to 2.7, which is what we're going to practice today, we're working with inequalities, meaning not equal, right? We've been doing equations where we use an equal sign. When we work with inequalities, we're going to use greater than, less than, greater than or equal to, less than or equal to. We're not going to use equal signs. Otherwise, everything else holds true, right? We still solve the inequality using algebra the way that we were doing all of them. But the problem is when it comes time to write your answer for an inequality. There's a few different ways to do it. Like, for example, if I told you that x minus 2 was greater than 10, that's not an equation, that's an inequality. Okay? So if I solve this guy, add 2, I get x is greater than 12. Well, how many numbers are greater than 12? A lot. Infinite. There's an infinite number of answers to this problem, right? One way is to write it in what they call set builder notation, which is basically just this. All x's that are greater than 12. That's one way to write your answer. But we also do what we call interval notation. It's an interval of numbers. And when we write that with interval notation, we're basically saying the same thing. X is greater than 12. But if you think of it on a number line, if this is a number line, and let's say this is 0, and this is 12, we want every number to the right of 12, right? So then it begs the question, what about 12 himself? Is 12 one of the solutions? No, because we said x needs to be greater than 12, and 12 is not greater than 12, 12 is equal to 12. That would only be true if I put the little line underneath it, right? Good review for you guys. So in interval notation, we use parentheses and brackets. Parentheses and brackets. So a parentheses, for this particular one, I'd put a parentheses on 12 and then shade in everything to the right, saying everything to the right of 12 is a solution. So with interval notation, maybe we have a solution where we say 3, 8. Now it looks like a coordinate, like 3, 8, like x is 3, y is 8. That's not what it is, even though that's what it looks like. It's not the coordinates of a point. It's interval notation. We're saying every number in between 3 and 8 is one of my solutions. But since we use a parentheses on the 3 and a parentheses on the 8, parentheses is what we call an open interval. We do not include the number. So are we including 3? No. Are we including 8? No. So think of it as getting really, really close to 3, but we don't quite get there. Like 3.00000000001 or something like that. And then think of it as getting really, really close to 8, but we never get there. 7.999999999, something like that. Okay? So what happens if I go to the second one? There's parentheses, and then this time there's a bracket. We do not include 3, because I used a parentheses with 3, so we're going to get really, really close to 3, not including him though. But this time, since I put a bracket on 8, that means we are going to include 8. It's what they call a closed interval. So bracket means include. Parentheses means get really darn close to it, but don't include it. So I could switch it around the other way, put the bracket with the 3. That means I am going to include 3, but parentheses 8, not include 8. Or if I go bracket, bracket, that means I'm going to include both 3 and 8. Okay? So if we do it on a number line, sometimes we use closed dot, open dot. Depends on what textbook you're using. Closed dot means the same thing as bracket, meaning we are going to count A, but open dot means we are not going to include B, or vice versa. If I put open dot on the A, that'd be the same as putting a parentheses on A. Closed dot on B means a bracket on B. And sometimes the number lines, instead of using open dot, closed dot, you can actually use brackets and parentheses right on your number line. So there's a lot of different ways that the notation can be expressed. And sometimes you might run into one on your quiz that says use interval notation, or it might say use what we call set builder notation. It doesn't matter, as long as you understand the vocabulary and you understand the notation. So if you run into trouble on that, let me know. But that was just my quick interval notation spiel for you there. A couple other things that are here. I put an old video on inequalities that I made from several years ago. You can watch it if you want. It's optional. I put a Math is Fun website. If you're a little shaky on inequalities and you need a little review on your greater than or equal to, less than, there's a little review. Did anybody learn the alligator mouth thing? That's the way I learned it, where the alligator just eats the big one. Technically, it's not very mathematically precise. I mean, it makes sense. The only problem with memorizing it where the alligator eats the big one is then you're like, wait a second, is that the greater than sign, or is that the less than sign? I don't know. That's the way I remember doing it. So that's there for your practice. And then I gave you a PDF of just a bunch of practice problems that you can practice here in class. They're just handwritten. You can write them on your own notebook. And then below that is actually the solutions to that. So obviously I'd want you to give it a try and see what you know what you're doing. But if you want to look at the solutions, it's right there. I'm not going to have you hand it in. I also posted the solutions to the ones that we were working on Friday, right? So basically I just want you to practice the 2.6 ones. I can help you out a little bit. And then if you're confident in the 2.6 and you finish those, go ahead and practice the 2.7. I'm only going to show you one other thing here. And that is when we're solving these inequalities. So there's no equal sign. Instead of an equal sign, we have a greater than sign or a less than sign, right? Or greater than or equal to or less than equal to. Everything we do algebraically, we do it the exact same way as we do it when we solve an equation. So if I add 10 to both sides, no problem. If I divide both sides by 2, no problem. There's a little wrinkle in that, though, when we multiply or divide by a negative, and I bet you guys already know where I'm going with this. What's the rule that you learned back in 8th grade? You got to flip the sign. Why do you flip the sign? Well, first of all, when do you flip the sign? When you divide by a negative or multiply by a negative, right? Why? Because your teacher told you to? Yeah. Does anybody understand why we do that? Let's say I told you that x was greater than 3. Fact. Write it down. x is greater than 3. Are we comfortable with that? Okay, that's an inequality. I have a left side and I have a right side. I could add 2 to both sides, and I could say x plus 2 is greater than 5. Still holds true, right? I could take both sides times 7. I could say 7x is greater than 21. We're still okay, right? All of this is good, okay? So if I look at a number line, and let's say this is 0, let's say it's 3, let's say this is negative 3. Right now, when x is greater than 3, can you visualize where x lives on the number line? Where does he live? To the right of 3. Somewhere over here. We're not sure how far, but somewhere over here, right? So I'm going to put in an x right here. Do you guys all agree that x would live to the right of 3? Okay, let's do this little negative thing that we do now. Let's say I take both sides of this inequality times negative 1, or divided by negative 1, doesn't matter. If I take both sides times negative 1, I would now have negative x and negative 3, right? Okay, if x is right here, and think of 0 as a mirror, if you took your number line and you folded it on 0, do you agree that 1 would touch negative 1? And 2 would touch negative 2, and 3 would touch negative 3, and 12 would touch negative 12, right? So what is x going to touch if I fold it? It's going to touch negative x. So can you visualize where negative x lives on the number line? Left. It's left of negative 3, about that far, right? So this is negative x if I folded it, right? So just look at negative x and negative 3. Is negative x greater than negative 3, or is it less than it? It's obviously less than it because it's to the left of it on the number line. But up here, my sign said greater than, and I just multiplied both sides times negative 1. Well, if I go like this and I keep the sign the same, that's actually wrong, right? Because I just proved to you that negative x is not greater than negative 3. It's actually less than negative 3. Hence, the rule that your teacher told you in 7th or 8th grade, whenever you multiply or divide by a negative, what do you got to do? Flip the sign. And now you guys know why. Do you feel better? All right. Okay. I'm going to let you get to work. You can practice the 2.6. You can practice the 2.7. You can work on your quizzes that are on your computer. I just want to be here to help. If you run into certain problems that you want to talk about, flag me down. Otherwise, I'm going to let you work.
One after we did this morning. And this bottom one kept throwing me off.
Okay, solve for y. So what did you do? You probably divided by n. So I'd go z plus r over n. And then I would subtract the v. Z plus r.
And then you divide that
over n. So why is there an extra v in there?
An extra v where?
I see v times n.
Well, the thing is that I did it the way that like we do it in chemistry, and it gave me the solution, and it had me write it like this.
Okay.
So I just accepted it.
So you're saying you got it right, but you wrote down something different?
I believe I got it right. Like I did it the way that I was taught. Like.
Let me grab a piece of paper quick. Let me grab a piece of paper quick. Hey. What I've found with that open math is they're spot on. They'll let you write it lots of different ways. I I can only do so many steps in my head, so I gotta see
Right.
dy plus v equals z plus r. So I bet you divided by n first, right?
So that's what I had.
Oh, I see what you did. Okay, yep. Okay, so if I divide by n, I get z plus r over n, right?
Yeah.
Then I subtract v,
Yes.
so now I gotta divide by d.
Yep.
So you got what I just wrote down, right?
Right.
Okay, so what that is, how did they do it? They put the d there and the,
I just
Oh,
don't know why it's
yuck.
an N over an N. That confuses me.
yeah, okay.
But it wouldn't let me write it any other way.
So this is the same as taking z plus r over n minus v times 1 over d, right? Same thing.
Right.
So if I did that, I'd get z plus r over nd minus v over d. And then I think they got a common denominator, nd and d, so I need an n and an n, common denominator.
Okay.
So then they went z plus r minus vn over nd. They got a common denominator and made it all over 1. It doesn't matter. It's
Could you multiply, like, when you're in this stage, like
Yeah.
this is 1 over d, can't you do the reciprocal?
Yep,
Put it on
and
top?
and that's what I did. So, but you got to do it to both because there's a minus sign, so you'd have to distribute to both guys,
Oh, gotcha.
right?
Okay.
So yeah, the d goes here, and the d also goes here, and that's what I did
okay.
here.
Right.
And then what they did, the reason they have two n's there is they got a common denominator.
So would it accept it if you had the 2d's?
Maybe. I don't know. There's 9 different ways to write this.
Right.
So it's really just a practice in fluency. I'm not sure how smart the system is. The directions might have even said, like write it in a certain format. I don't know if it did or not, but.
I'm just doing some of the quiz for 2.5,
Mm-hmm.
the quadratic formula.
Mhm.
And when I have the 153 squared, there's no really perfect square for it.
Correct. It's going to be a big, ugly decimal.
Correct.
Yep.
So what do I really have to do next?
Well, you could leave it like that. Are you thinking for the online quiz?
Online, because I
What
need to...
did the directions? Do you have it up right now?
Yeah.
Did the directions say to write it a certain way, or is it multiple
It
choice?
wants me to get the x values.
Okay,
That's why
solve by factoring. Oh, I see what's going on here. So,
I don't know
are
if
you
I
sure
can complete it
you
or
might
if
have? Are you sure you did that right though? Because it's negative b, so 3 plus or minus b squared minus 4ac 9.
Would it be a subtract?
What's that?
Eight
That's
times
8
9.
is 72. 8 times 9 is 72.
Okay, that's where I messed up.
And then you're going to get 81, right?
That'd be perfect 9.
Yeah, that's why. And notice it said solve by factoring.
Yeah.
And the only reason a problem would say solve by factoring is if it's factorable. If it's going to come out to be an ugly awful,
Yeah.
it's not going to say solve by factoring.
Right.
So what you're going to find out now is your number is going to come out to a whole number.
Yeah.
So if you'd have followed directions and factored, you'd have been there, right? That's okay though. I did want to share one example together with you guys. And my experience tells me, this is number 8 from the 2.7. This is an inequality, and it's an absolute value. So we got two things going on here, right? Now, I have tons of students who want to do this. Add 2 to both sides, and then say the absolute value of x is equal to 7. So x is less than 7 or negative 7. And they get all mixed up and it's all goofy and awful. Okay? There's more going on to this than you might think. So let me see if I can get my pen to work. Wait a second. Here we go. This is where I said on Friday, when we do absolute value, we want to think about it as a distance away from 0. Okay? So my brain gets mixed up when I just start trying to do paper and pencil computation. I got to sit here and say, you know what? Here's a number line. Here's 0. Here's 5. And here's negative 5. What do I know about the distance away from 0 of x minus 2? I know that it's less than 5. So if x minus 2 lived on this road, if it lived on this number line, it has to live inside 5 and negative 5. Do you guys agree? Like if I put a barrier right here and a barrier right here, it has to live in here. It cannot live. Why does this do this to me? It cannot live on the outside. Right? So now I need to set up 2 scenarios. I'm going to set up a scenario for negative 5 and I'm going to set up a scenario for 5. What do I know about x minus 2? I know that it has to live to the right of negative 5. It has to live to the right of negative 5, correct? It has to be greater than negative 5. What else do I know? It has to live to the left of positive 5. So it has to be less than positive 5. X minus 2 has to be less than positive 5. I now have 2 inequalities that I can solve. If I add 2 here, x has to be greater than negative 3, and if I add 2 here, x has to be less than 7. Greater than negative 3, less than 7. So if I was doing that on interval notation, greater than negative 3, less than 7, my interval notation would be parentheses, negative 3, 7 parentheses. If I was doing an interval notation. Is that what the solution says to that one? There's a lot going on there, right? You really got to keep your stuff straight in your head. And in my opinion, it really helps to draw it out on the number line. Otherwise, it's easy to make a mistake. When you go to number 10, notice it's the same thing, except this time our absolute value is greater than 18. So if I drew a number line, and here's 0, here's 18, and here's negative 18, I need to be 6 minus 3x has to be greater than 18 units away. So can you see where 6 minus 3x would live? He'd have to live over here, or he'd have to live over to the left of negative 18, on the outside of 18 and negative 18, as opposed to the inside. Do you see the difference? Because this time the distance has to be greater than 18, whereas the previous example, the distance was supposed to be less than something. So again, I can set up 2 inequalities. I can say 6 minus 3x has to be to the left of negative 18, and 6 minus 3x has to be to the right of positive 18. And I set up my 2 scenarios and I solve. But this time we're not going to get an interval that goes from left to right. We're going to get an interval, and then we got to jump, and then we're going to get another interval. Okay. I'm going to shut this off. So you'll see on the solutions document that I provided, I draw the picture on there too, kind of like I was just showing you. I'm not saying you have to draw the picture. I'm telling you that it helps to kind of keep your brain straight.
Just another practice one. They want me to solve for m, which I did. I got half of it right with the 5. Do I just have to plug that back in?
So how many answers should you be getting?
I thought it'd be 1.
Nope.
But it's 2.
Every time we do a quadratic, we're going to get
2 answers.
2.
Okay.
Yep. So it's not just 5, because 5 works. 5 squared minus 25, so it's 25 minus 5. That gives me 0. But what else works?
The opposite.
The opposite of
Reciprocal.
5. Not reciprocal.
The opposite.
The opposite, which is what?
-5.
Negative 5, because isn't negative 5 squared also 25?
Positive. Yep.
Right. So every time we do a quadratic, you're going to get the 2 answers. Hence, when you use the quadratic formula, negative b plus or minus square root of b squared minus 4, you see that's where there's always 2.
Because can you, like I tried to plug this into Desmos, but it's whenever I plug in the answer, it says it's incorrect.
So you tried graphing it. So negative 2x minus 1. So I could just graph negative 2x minus 1. So you, whether you're using Desmos or GeoGebra, sorry, you're going to get the same graph. Oh my gosh, my computer. Come on. No. Don't save, don't. So it's negative 2x minus 1, right? Now you could solve this algebraically without graphing at all if you wanted to. It says find the x-intercept. Well, the x-intercept is where y is equal to 0. Find the y-intercept, that's where x is equal to 0. You could just do some mental math and plug it in and figure it out. But if you go, is it negative 2x minus 1? So the x-intercept is at, what is that, negative half? Is that what you tried? Oh, I see what you did. So when you graphed it, you typed in y equals negative 2x minus 1?
Yeah.
And what does that give you? Y equals negative 2x minus 1? Still gives you the same thing, right? Still gives you that graph, right? So the x-intercept was negative half, and the y-intercept was negative 1. Did you try that? Negative, you could either do 1 divided by 2 or you could do 0.5. I better to let you do either one. But yeah, go ahead and use the fraction. You can try negative 0.5 too. Yeah, go ahead and invalid notation. Oh, it's asking for a point. Parentheses, so they want you to go negative half comma 0, like a point. Does that make sense? Yeah, that's kind of, they weren't really specific there. There you go. That should work. So the y-intercept would be 0 comma negative 1. There you are. Yep. So I just want to remind you again, remember when you guys click on that folder to go and take those quizzes? Inside that folder, when I go to chapter L2, say I'm on 2.7. Here's a little video, absolute value inequalities. So when Jamie explains it in class, if it still doesn't make sense, there's another video for you to watch, right? Lots of resources for you to practice on.
I'm not sure how to go about this if you're trying to take out 3 and I get these horrible numbers.
So, well, here's the good thing, is once you take out 3, keep in mind that this is equal to 0, okay?
Okay.
So if this is equal to 0, now a cool thing you can do here is just divide both sides by 3, cancel, and 0 divided by 3 is just 0.
Yeah.
So it goes away, right?
Yeah.
So you've gone from very difficult to medium difficult,
Yeah.
right? So the question is, can you mentally turn that into 2 parentheses?
The answer is no.
And this is
I
where it comes to
struggle
practice.
with factoring.
This one isn't awful because there's only 2 ways to get a 2a squared. Like,
Okay.
think about what would have to go in the first and the second spot. What would you multiply? What times what gives you 2a squared? 2a
2a and 1a.
and 1a.
Yeah.
Exactly. So fill in the 2a and the 1a. Okay? So now it's just trial and error. Okay? We know that we have to get 5 when we're done, right?
Yeah.
So, and this one's not too bad either, because what times what gives you 5?
5.
5 and 1, right?
Okay.
Except notice that we need a negative 11. So it's actually we
Negative
had negative
5
5 and
and
negative 1. So
Okay.
now, before you fill it in though,
Yeah.
is the negative 5 going to go there and the negative 1 here, or is it going to be the other way around? You got to ask yourself, because one of them is going to get multiplied by 2 and one of them is going to get multiplied by 1. So this is where that trial and error comes in.
Would the negative 5 be here? then?
Correct. Because it's going to get multiplied by the 2, right?
Yeah.
So now, distribute or FOIL that back out in your head. 2a squared
Yeah.
minus 10a minus 1a gives me
Negative
11a, and you're done.
Okay.
The heavy lifting's now done.
Thank
Now you got to set each guy
Yeah.
equal to 0, and you're going to get your 2 answers.
you.
Yep. I know, that's just it's a practice thing. It's a total practice thing. That's why I gave you all that.
Say it makes sense.
So again, the math is fun website. I gave you the little thing where you could, on the PowerPoint, where you could move the tiles around in practice. Like, you know how to do it. You're just not as fast as you want to be.
Yeah.
So you just got to practice a little bit. It's just algebraic fluency. By the way, when you guys come back on Wednesday, your test is going to be just like those online quizzes that you've been working on. Okay? It's in the same format. So
and I said this on the first day of class, but when you guys do these quizzes, you can just do them over and over and over and over and over again, or generate a new one, right? When I give you the test, you can click submit, and it'll tell you if you got it right or wrong, and then you get one more chance to submit a second time. And if you get it right, I think I have it set up so that you get half credit, and if you get it wrong twice, you move on with life. Okay, so that's the format that it's going to be in. And Harmony and I were talking earlier, typically that system is pretty good at accepting multiple ways to write things in, but every once in a while you might put something in and it might tell you that it's wrong, and you're like, no, it's not, that's right. Like, if you run into that scenario, let me know, because every once in a while the format or the way you write the fraction in might not be the way it matches up with the computer. But I've found that computer accepts many different versions of the same answer, and you're usually good to go. It'll even tell you invalid entry. Have you guys noticed that? If it's an invalid entry, something's wrong in the way that you're typing it in.
do this problem on the quiz, and this one looks a lot like it. And when I did it, I got 8. Now I don't understand how I got 8.
So if you, there's a little wrinkle here. If you look at that x to the 2/3, what that means is it's x squared, and then take the cube root of it. So if that numerator, if the numerator is an even number, 2, 4, 6, 8. If we have x squared equals something, we know we're getting 2 answers, right? That's why this guy has 2 answers. Okay? So the one that you were just looking at, which one was it?
This one.
Okay. Notice that one is cubed.
Yeah.
So x cubed is only going to have 1 answer. So if you think of it this way, let's say x squared equals 9. 2 answers, right?
Yeah.
X equals plus or minus 3. So anytime we have an x with a fraction, if it's an even over some denominator, we're going to get 2 answers.
Okay.
If it's x to some odd over a denominator, we're only going to get 1 answer, because like if I gave you x cubed equals 8, there's only 1 answer to that. And the answer is 2, right? 2 times 2 times 2 is 8. X equals 2. It doesn't equal negative 2, because negative 2 is different. That would be the answer to x cubed equals negative 8. The answer is negative 2, because negative 2 times negative 2 times negative 2 is negative 8. But notice how 1 answer for this guy, 1 answer for this guy. That's because that's an odd number and that's an odd number. So that's a little wrinkle for those of you that were working on those checkpoints from Friday. It's 5A and 5B. Notice that 5A only has 1 answer. Why? Because it's 5x to the 3 halves. It's cubed. It's an odd. There's only 1 answer. But for B, it's x to the 2/3, meaning there's going to be 2 answers because it's x squared. So you should only get 1 answer for the one you're working on.
So do I want to take the times?
Absolutely. Not times 5/3, raised to the power of 5/3.
Okay.
So 8, perfect. There you go.
Okay, that makes more sense. I missed the
Mm-hmm. And now subtract the 1 and you're done, right? Yep.
I guess I have one question. So I kind of put this in the quadratic formula right away.
Yep.
I kind of got a bad number again.
Yeah, what's the...
So then it's, I pulled up the video and it's doing the GCF, but I feel like it's going to be difficult with these high numbers.
It's gonna, yeah. So what you could do from the get-go is like divide by 5, for example. So m
Okay.
cubed plus
They're smaller.
4m squared
Yep.
minus, is it 21?
Yep.
So, and again, it's probably factorable, well, especially,
Yeah, with
If-
those numbers.
yeah, and you don't know it's gonna be, but again, we talked about this in class the other day, so what is it, 5, or 520 and negative 105? So 520 minus 105 equals 0. So if I divide by 5, it's m squared plus 4m minus 21. Right away, what method should I choose? Well, if you want to work as little as possible, which we all do, let's try to factor it.
Yeah.
So are there factors of 21 that are going to add up to
3 and 7.
4? Yeah, 3 and 7. Like, I don't have to pull out that quadratic formula. That's way too much work.
there.
Yeah, it's way too much work. So I'm going to go m and m plus 7 and minus 3, right?
Right. Yep.
Yep. So my 2 answers are negative 7 and positive 3. It'll work with the quadratic formula. You
Just
calculated something wrong.
Yeah.
Yeah, yeah. Any parting questions before we're out of here today? I'll come see you
Everybody know what to expect on Wednesday when you come to class. If it takes you longer than class period to finish your test, no worries. I'm not going to put a time limit on you. So you can, in fact, I don't even think there's class in here after our class, so we can even sit in here for a little bit longer and finish if you need to on your test. Okay, see you on Wednesday.